Hey guys, welcome back. Good afternoon. Well, it's not really afternoon yet, but good morning, I suppose. Welcome back. It's Critical Thinking. This is our Orange Coast College Tuesday, Thursday section from 11:10 to 12:35. It's April the 23rd, and we have an important meeting today. We're going to start talking about a new chapter in the book and discuss, the remaining meetings in the class. So we're getting closer to the end of our semester. We just have 2 chapters to go through. There's going to be a quiz next Thursday on this current chapter that we're going to talk about, which is all about science. So by being prepared, taking good notes, tuning in today and Tuesday, you'd be good to go for your quiz next Thursday. And then after that, we'll get looking at chapter 9, which has to do with ethics. And then it's just the final exam after that. So I'm going to assign the last homework assignment to you guys after the quiz. So we'll talk about this more at 11:10 when I have the maximum attendance, and so I get as many people to watch and see the announcements as possible. Okay. But anyway, to anybody here watching, welcome back. I hope you guys are having a really good day, good week, to the best of your ability, good semester, and we just keep on going. Let's see here, just getting my things all set. Okay. So just a few minutes, I'm just hanging in and waiting till 11:10. But anybody, feel free to say hi. You guys know the routine by now. We have these live streams, and you can always chat, throw in a comment, question, or anything else. Hey, Long, good to see you there. Hope you're doing well wherever you're at, back home, away from campus. Hey there. Hi, Brian. Good to see you. Hey, Carmen. Awesome. Good to see you too. And Sebastian, nice to see you too. Great. Cool. Hey, Madison. Good to see you there. Miss having our face-to-face meetings. I never thought that I would want to be at school. Can you believe it? But kind of miss it. It's not as fun in certain ways to not have the live face-to-face interaction, being able to read the room and all of that. At the same time, there is a certain convenience to just being at home. I guess we can all kind of relate to that, but prefer not under these circumstances. Hey, Sandy, nice to see you too. All right, getting close to our class time. You said you struggled on the homework mostly from finding the ads. Was this assignment supposed to be really tough? I mean, I don't know. Everyone's got a different experience, right? Some people do great on it, I guess. Some people have struggles. You're asking me? I don't know. I don't think it would be tough, but maybe for you. Sebastian, I agree, but on the upside, I get to sleep more. Yes, it is definitely nice to be able to sleep more. I'm a big sleeper, so no complaints about that. Hey, Connor, good to see you there too. All right, cool. Well, guys, it's pretty much class time, so welcome back, everybody, and hello, Bill, and to all the rest that are chiming in and sending me a couple of nice, friendly greetings. It's always nice to chat with you guys and see you here in this live stream, so welcome back. Anyway, we've just got another meeting today, and our class is right on track. There's been no changes. I don't know what's going on with some of your other classes. I've heard people tell me all kinds of sad stories about disruptions to the way the classes are being delivered and professors changing up the evaluation and stuff. But whatever. I'm not doing that. This is just going to be exactly like you guys expected from the very first day. The syllabus is being delivered in the same way on the same dates. So, I mean, the consistency is nice, but it also means that you guys can't slack off and just assume the semester's over, because it's not over and you're still being evaluated. But thank you guys. I'm sure all of you guys turned in your homework. Today was that due date for your third homework. So make sure, if you have not done it, if you haven't hit send or whatever, just make sure I get it. If I receive the homework assignment from people today, I'll consider it to be on time. But once it starts to roll into the next day, then it's going to get late credit deducted away from it. So do your best to just make sure you get that into me. You know, I gave you the instructions online, so you can go back and look at them again if you need. But anyway, moving on from that, we're done with fallacies. We're done with media criticism. Well, the fourth homework actually has something to do with that, but I'll save that little detail until after the next quiz. So in the immediate short term, the next thing that we're all going to be worried about is the quiz next Thursday. So you have a quiz on Thursday next week. That's Thursday, April the 30th. And basically, this is going to be a quiz on Chapter 12, which is all about science. And we have 2 meetings to go over Chapter 12. So today and Tuesday are the 2 lectures that are dedicated to going over the material of Chapter 12. So that's the plan. Today and Tuesday lecture on Chapter 12. Next Thursday you have a quiz. Then after that we're going to look at Chapter 9, which is the last chapter in the book that we'll study. And we'll spend a couple of different meetings on that. And then finally, we'll get to our final review and the final exam. So just giving you guys the updates, but if you want, you can always look at the syllabus and you can just check the schedule there. It's the same schedule that I'm mentioning here in the live stream. Okay, so any random questions anybody has about anything? I don't know. You can let me know. If you do, at any time, just throw it out there and I'll take them as they come. But aside from that, I guess. John, you say this. I noticed for the announcement on the homework that it didn't specifically say that it was due by class time. Okay, so it's not. Just turn it in. You know, turn it in whenever you're ready. But it's due today, isn't it? So make sure I get it today if you could, and it'll be on time. Like I said a couple minutes ago, right? Send it to me today. I'll consider it on time. Does that make sense, John? Are we all on the same page? I'm telling you, you can send it to me by the end of the day. So are we clear? I would have liked it to be by class time, but I don't care. I'll be lenient. I'll let you turn it in by the end of the day without a deduction and credit. Making sense to you, John? Hopefully you heard me. So I'm saying turn it in by the end of the day. If you haven't had time yet to do it, make sure I get it today. Hey, Veronica, and hey, Jaden. Okay. Is everything good? Are we all on the same page now, at least for the time being? I'm happy to keep going with other questions, but yes, turn in your homework. It's due today. If you didn't turn in yet, turn it in to me today. Worst case is you don't turn it in at all. But if you turn it in today, you get credit. If you turn it in later than today, it's going to start losing credit. Okay, so look, Chapter 12, that's our topic now. Let's get into this. Chapter 12, and what is it about? It's about a very important topic, science. All right, science. So in this chapter, okay, so it opens up with a little bit of a description of a current day, scientific issue and a problem for human society, and that's the issue of global warming. So global warming is a phenomenon that's caused by the accumulation of greenhouse gases in the Earth's atmosphere. And when that happens, it pretty much creates a greenhouse effect, which, like an actual greenhouse, causes heat to get trapped. Now, if this was just happening on a small scale that couldn't really have any measurable effects, I guess it wouldn't be a big deal. But actually, the global rise in temperature is causing Arctic sea ice to melt, so that's causing water levels to rise. It's having all other kinds of destabilizing effects on the food supply, the ecosystem, and we depend on all that for our survival as a species. So the phenomenon has really increased in scope over the past 100 years. Sea levels have gone up by over 7 inches in the last 700 years. And according to some models and good projections, even conservative estimates say that we may have another as much as a foot of sea level rise if the problem doesn't get somehow under control in the next part of this century. In recent decades, the heating trend has accelerated. So it's not like it's just a steady, stable measure of heat over time. It's actually increased significantly over the past few decades. The hottest 11 years ever recorded. Actually, I can add a couple numbers to that because I'm talking about numbers from the 3rd edition textbook. But they've already got the 5th edition textbook out now in 2020. This is the 2014 book. And basically, since then, we've added a couple of additional hottest years ever on record. So meteorological data that charts the global average temperature has been kept since the 1850s. And in that entire long track record, all of the hottest years on record are clustered towards the tail end of the timeline, essentially since 2000, and even more so since 2010. And it's a little bit of scary fact to consider, because in a worst case scenario, you're going to have whole coastal regions that'll be underwater. You know, when I had a big meeting at the Orange Coast College campus, they had Flex Day for all faculty and staff, and they talked to us about certain projections according to which maybe there will be significant regions of the coastal area of Orange County that will be subsumed by water by the turn of the century. Now, some of us might not necessarily be the most impacted by it, I guess, because we have our lifespan and everything, but we are starting to see devastating impacts that will, in fact, touch our own lives, if not our children and grandchildren for sure. And so, as critical thinkers living in a coastal area especially, we need to be able to take scientific information and evaluate it carefully. We need to be able to see how to evaluate and interpret scientific facts and claims that we see reported in the media and through other sources, and know how to do our own research scientifically. So we're going to learn a little bit today in Chapter 12 about the history of science, identify some of the basic assumptions that are built into the practice of science. We'll talk about the scientific method, and ultimately we will talk about the distinction between science and pseudoscience, which is a fancy word for basically fake science, like crystal ball gazing and palm reading and all that stuff. Okay, so I guess the best place to begin is to just talk about the term science itself and give a definition. So science, and this is what the text definition is, it's just reasoning from observable facts to testable explanations for the facts. Okay, so in science, we start off with observation of the world. So the first thing you do is you just observe the world and you note that there's certain things that are happening, in other words, facts. But you don't just want to say, well, here's something that happened. A scientist is trying to explain why it happened. What's the cause? What's the cause-effect relationship here? So, I mean, imagine yourself a person in prehistory that just goes out and sees that here's a volcano erupting. Wow, that's something. If you're a scientist, though, you wouldn't just be like, volcano erupted. You want to know why. Like, what are the causal factors that cause such an event to happen? You see a thunderstorm, lightning storm, it's happening, right? But we don't just leave it at that. Note that the thunderstorm happened. You're trying to provide an explanation for that event. So scientists want to give explanations for why things happen so that we understand why they happen, and so that we can also, in many cases, exert some control over the forces of nature and the world around us to make it better for human beings. These explanations that we try to give for the observed facts are supposed to be explanations that you could test in terms of their credibility and accuracy. So scientists don't just say, take my word for it. They say, well, if you don't agree with this explanation, here's the test that you can perform to verify that it's the correct explanation. So scientists begin looking at facts, just observing them, collecting that data, and then afterwards trying to give explanations for the occurrence of those facts that could be tested by other people for their truthfulness. Okay, so that's what science is all about, getting to the explanations for things based on the observations that you have of them. And when these explanations are provided, they're supposed to be able to be tested by both the individual scientist or researcher, but also the other members of the scientific community. So there's a lot of replication that goes on in scientific experiment. When a scientific experiment verifies or validates a hypothesis, it's expected that other people will look at those results and try to duplicate them. And the more times we see a similar outcome, the more credibility is given to that hypothesis. So that's the first thing I want to mention, just the definition of science. Next up, we're going to talk a little bit about some important figures in the early history of Western science. But just so we all are clear, right, science is very important. It's the major source and method for understanding any facts about the world, from the biggest to the smallest scale of description. If you want to know anything about how the world works, if you want to know how, planets form, or how volcanoes erupt, or how earthquakes happen, how hurricanes happen, how photosynthesis occurs, if you want to know how stars coalesce, or how light propagates through the vacuum of space, if there's any question, biological, chemical, physical, having to do with astronomy, that you're interested in, the number one place that you'd go to try and determine quality answers and information about it would be the scientific field. Okay, so science, we need it. We need it because if we don't have science, we can't really understand the world we're in, and we don't know what to do in order to make it shaped best for human needs. So it's important. Okay, now I'm going to talk to you next about a couple of important people in the early history of Western science. So erasing this, and we're just going to go into these important key figures. So one man that we want to mention is this guy named Nicholas Copernicus, but we'll just talk about him as his last name, Copernicus. So Copernicus was a Polish astronomer. He lived from 1473 until 1543. So let me give you his little bio here. Polish astronomer. Who discovered the heliocentric model of the solar system. Who discovered the heliocentric model of the solar system, which replaced the previous geocentric model. Okay, so let's see if some of us can make a judgment here about what these words mean. It says he's a Polish astronomer and he discovered the heliocentric model of the solar system. That was very important because it replaced the older classical geocentric model. Now, what do you think heliocentric means, if you had to guess? And I guess you do. So what do you think would be the meaning of that term or concept? Heliocentric. What do you think? Helio does mean sun, yes. Centric could be, I think it's kind of, the etymology gives it away in a way, but we're on the right track with saying sun. That's correct. Helios is an older term, I think of Greek or Latin for sun. But what is heliocentrism? What do you think? Good, exactly, John. So heliocentrism is the idea that it is the sun that's at the center of, no, Veronica, it's not about thinking of the sun as a sphere and talking about its radius and diameter. No. We're talking about the structure of our local cosmos. So what he discovered is that the sun lies at the center of this solar system and that all the planets, including the Earth, rotate around it. Sun-centered, heliocentric. This replaced the older idea of geocentrism. Now, what do you think geocentrism means? If heliocentrism means that the sun's at the middle and other objects orbit around it, what do you think geocentrism is? Which is what people believed before Copernicus discovered heliocentrism. Yes, correct. It was the belief that the Earth was at the center. Geo refers to Earth. Centric, again, refers to something being centered. Earlier in the class, we talked about like ethnocentrism and egocentrism. So to have something centered, the prefix tells you what's at the center. So heliocentrism is the fact, really, that the sun is at the center of our local cosmos and not the Earth. Now, why was that such a revolutionary thing? First of all, how did he discover it? Well, telescopes that were newly invented and more powerful in his day and age started coming into the public use, or at least I don't know if I should say widespread public use, because most people in that time period wouldn't have been like literate members of the aristocracy that could actually write and conduct such tests. But anyway, Copernicus was an astronomer, and he used these newly invented and better telescopes to conduct observations of the orbits and motions of the celestial objects. And using those observations and tracking them, he was able to demonstrate and prove that the sun is at the middle. Why was that so important? Well, prior to that, the orthodox, belief was that the Earth was the middle. And why was that so important to think that the Earth was at the middle? It had a lot to do with deference to religious orthodoxy. It was considered very important to the church that it was believed by all people that God, who created the planet Earth and who created mankind in his own image, would have put the Earth right in the center, because everything should revolve around us if we're the children of God, right? So the church thought that it was a heterodox, unorthodox idea to suggest that we don't have pride of place in this universe, that we're just in some kind of random peripheral location. But Copernicus and Galileo also were able to prove otherwise just by conducting observations. That was definitely something that was a challenge to church orthodoxy. In fact, Galileo, for example, who had similar findings, was forced to recant his testimony under pressure of the church because they were threatening him with death and execution. Now, of course, as time has passed, the church has issued formal apologies to Galileo and his descendants, because it's well known and understood by everybody based on the much more advanced methods of observation that we have today, orbiting satellites and Hubble telescopes, everything. I mean, we know for a fact that the Earth's not at the center. In fact, not only are we not at the center, we're the third planet rotating around the sun. We're not at the center of the universe. We're not even at the center of our local cosmos. So what this shows was that by using the tools of observation and scientific method, we could overturn or repudiate beliefs or ideas that had been held as cherished beliefs by the church. You see, prior to the modern era that we're living in, pretty much a lot of the establishment of these constitutional democracies and liberal states like those, prior to the Renaissance, really, in the early Christian era and the medieval period, the church was a dominant institution. It jointly administered functions of the state. So there wasn't this whole concept of separation of church and state. And if you were found to be saying something that was out of line with church doctrine, then, you could have been punished, jailed, executed, or whatever. So this is a breakthrough moment, and that's why a lot of times people call Copernicus one of the forefathers of the scientific revolution. This discovery of heliocentrism opened the door to a whole range of new scientific discoveries that would go further and further away from just traditional church doctrine. Okay, so anyway, that's one important man's name and contribution, the discovery of heliocentrism by Copernicus. Another person that we would mention here that's talked about in the book is this guy who I'm going to put up there. His name is Sir Francis Bacon. Okay, so Bacon, his lifetime was from 1561 until 1626. And he's basically responsible for establishing the steps in the scientific method. Okay, so okay, so that's Francis Bacon, knighted by the British Kingdom, but anyway, Sir Francis Bacon. He formally set forth and defined the procedures and steps in the scientific method. We're going to talk today a little bit about the scientific method in a moment. Well, we might get to it on the Tuesday lecture. Depends on how far today's meeting goes with the notes. But basically, the scientific method is a method probably a lot of you guys learned a little bit about, at least in either high school or even elementary school. It's the process where you start by observing the world, identifying an unexplained phenomenon, then trying to provide a hypothesis as to what is the cause of that phenomenon, and then generating an experiment which can test whether this hypothesis is true or not. The steps of the scientific method have not really changed significantly since Francis Bacon established it. No, not really. It seems that there's no real way to improve on the wheel, as it's so to speak. It's just a fundamentally sound procedure. You observe things, you collect data, then you try and provide a hypothesis that explains the observed data, and then you try to test it. Now, of course, the tools of observation that we have at our disposal now are far superior to anything that Bacon would have been able to deal with. So, like, we have telescopes, microscopes, cloud chambers. You know, we are able to map out the human genome. We know the periodic table of elements, and we actually have electron microscopes that we can use to see atoms. We can control the electromagnetic frequencies and harness microwave radiation or gamma rays or, you know, X-rays. So we have a lot more applications of scientific knowledge today and technological applications of scientific discoveries. We have greater tools to use to conduct the observations, but the basic methodology is the same. But that's a very good question too. So anyway, that's Bacon's contribution. And so we all owe him and I guess Copernicus a great debt of honor, since we're living in a world in some part shaped by the significant impact of their discoveries and their lasting contributions. Okay, so I want to talk to you guys next a little bit about what are some of the basic assumptions that are built into science. There are certain fundamental baseline assumptions that have to be made for scientific practice to even proceed. So I want to tell you guys what are some of these built-in basic assumptions of science. Okay, so that's what we're talking about now. Assumptions behind science. Okay, assumptions behind science. So the first one is a word actually that we're kind of already familiar with, perhaps because we learned about this concept when we studied the topic of knowledge a few weeks ago, and that is the concept of empiricism. Maybe somebody has a memory. What is empiricism? What is it though? It's a belief about where most of the human knowledge comes from. Any faint recollection of that? According to the view of empiricism, most human knowledge comes from where? Let's see who's got it. You can let me know. Empiricism, most human knowledge comes from observation and the five senses and experience. Correct, yes. So that's the right definition. Empiricism, the belief that most human knowledge most human knowledge comes from the five senses and observation. Okay, so that is a basic, assumption of science, that most of the knowledge that we can get as human beings comes from the things that we can perceive with our five senses and observe in that way. So the five senses, as we remember, are sight, taste, touch, hearing, and smell. And using those abilities that we have got to see, taste, touch, hear, and smell things, we collect observations of the world, and we are eventually able to discover facts about the world derived from those observations. So science is really fundamentally built on the idea of going out and observing things, collecting the observations, and then trying to make sense of them by means of theories and hypotheses. So, of course, science has to assume that we can get knowledge by doing that. If you didn't think that we could learn anything through observation, then science really wouldn't have the ability to provide us with any stable knowledge. Like if you thought that observation would lead you nowhere, then science would basically be pointless. Since science is based on the concept of conducting observations, it has to assume that that would lead us towards knowledge. So empiricism is a fundamental assumption that's built right into the whole concept of doing science. What's the assumption again? Just the assumption that we can actually get knowledge by using the abilities we have to perceive with our five senses. Now, sometimes when we observe the world scientifically, we use tools that allow us to enhance our ordinary physical five senses. So when you look through a microscope or telescope, that's boosting up the normal powers of your vision. But when you have a stethoscope on your ear, if you're a doctor, you know, whatever, then that's giving you a more enhanced ability to hear sound waves than you would have with the ear unaided by the device. So sometimes, you know, technological features of the world allow us to conduct observations in a more precise way, but at the end of the day, we're still just talking about conducting observations and then basing theories of the world on them. And so we have to assume that that leads us towards knowledge. Otherwise, what would really be the point of collecting the observations if they couldn't provide knowledge in the end? So that's one assumption of science, empiricism. Okay, and each time I have a new assumption, I'll just erase and clear the board so that we have plenty of space. You know, it's not a full whiteboard like we would have in a classroom, so I have to frequently, you know, clear it off and create more notes. Okay. So yeah, the next one is the concept of objectivity. Okay, so this assumption behind science is the belief that we can learn about the universe as it really is without any bias. Okay, so okay, so another big assumption of science, and let's have that discussion about this concept. Let me try to work with maybe your already established vocabulary and everyday common sense. Because I think that probably even if it's not the word or topic that you always speak about in everyday life, I think you probably have at least some general notions about what the difference between objective and subjective is. And so let me go building a bridge to this from what maybe you already have a thought or understanding of. So let me give you this statement and tell me if you think it's objective or subjective. Vanilla is the best ice cream flavor. Is this an objective or a subjective statement that vanilla is the best ice cream out there? What do you think? What could it be? I'm giving you two options. I'm thinking maybe you have a good idea about that. Yeah, it's subjective, correct. Why isn't it just an objective fact? Well, because it depends on a person's taste, doesn't it? It depends on a person's point of view and opinion. So maybe relative to me, vanilla is the best flavor. In fact, I really do like vanilla, even though a lot of people find it boring because I think it pairs well with so many other things. But nonetheless, that's just my view, and you may have a totally different view. But that's okay because it's not claimed as an objective fact. It's claimed as a subjective opinion. Okay? But if I tell you that the moon is orbiting the Earth, do you think that's objective or subjective? I mean, let's see. Hopefully you would have the right intuition here. And I know I could just wait for your comment, but I'm hoping that everyone's on the same page here. That's an objective fact, right? The moon being up there and orbiting the planet Earth isn't just like how I feel today or what I think about, you know, the quality of an ice cream flavor. It's just an objective fact about this universe. It's something that does not depend on my views or beliefs. It's real and it's true, whether I agree or not. So what are objective things? What are objective facts? Objective facts are how the world actually is in and of itself, independent of how anybody feels or thinks about it. So when we talk about a person's attitudes or feelings towards something, whether they judge it to be good or bad, sometimes we think that's a subjective belief or judgment. But objective facts are the things about the way the world actually is in itself, in the actual reality. So what scientists believe is that there is an objective world, and that we can come to know about it as it really is. And that when we get to that knowledge, that we will not just be looking at it through the framework of our own biases, but that we will come to a clear-headed, rational, objective understanding of reality. Because look, me and you are people in this reality, but there's a reality outside of our mind. It's not like when you were born, the universe started existing. It's always been there, or at least it's been there before you for sure, and it'll be there after you too. So there's a world, what it's like doesn't depend on what one individual subject thinks about it, but just how it is in itself. And the goal of science is not just to talk about our inner thoughts and feelings and attitudes, but to talk about and learn about the way this universe and world really is. So of course they assume that it's possible to get to the truth, the objective truth, and that when we get there, we're not just, again, reflecting our biases or prejudices or whatever. So, okay, like, there's a planet Earth. I would say it's objectively a fact that it's a sphere and that it's not a flat disk. Can two people disagree over that claim? Sure, but there's only one fact about the shape of the world. So what scientists are trying to do is get to the correct facts, to have the correct, true appreciation of objective reality. If there was no ability for us to ever get to objective truths, then why would we care about even practicing science? We would end up at the end of the day just talking about our various interpretations of data, but we would never actually have the ability to say that these interpretations are true. So anyway, another major basic assumption of science is this one, objectivity, that there is an objective world, that we can learn about it how it really is, and that we will be able to do that without bias. A good scientist should be able to do that. Okay, so next up, we're going to move on from there. So we've given you two basic assumptions of science. Next is the concept, what's called materialism, okay? Okay, so this word materialism, as it is used in scientific discourse, it doesn't have the same meaning that it has in pop culture discourse. Okay, so I just want you guys to know there's this possibility for equivocation on the term, and I don't want us to have different misunderstandings of the term. You have maybe heard the word materialism when you've thought about people that just care about money or how they look or how people, how popular they are. So you might say, oh, this person is so materialistic because all they talk about is like their possessions and just trying to impress people or whatever with their belongings. But we're not talking about materialism in that sense. So please just eliminate that whole association from this, at least, presentation of the concept. Because the concept of materialism in science has nothing to do with that. Instead, it's this point of view. It's the idea that everything in the universe is made out of physical matter, including us and our consciousness. Okay, so everything in the universe is made out of, like literally built out of physical matter. Quick question before I finish writing this definition. Who could tell me what is the word for, like, usually the people use this word to stand for the most minimal unit of matter. So like physical matter, tables, chairs, human bodies, everything's made out of matter. But when you break it down to the least element, what's the word for that? Matter in its smallest form. They call them what? Atoms. Yes, good, correct. So I'm just going to put that here in parentheses because that's what physical matter basically is. At the most minimal unit of description. So everything in the universe is made out of physical matter, in other words, atoms, including us, and this is key to the definition, including us and our consciousness. So everything's made out of physical matter, even us, even our consciousness. So what this claim is saying, or what this viewpoint is, John, you're asking this question, so let me take your question, I guess, as I see it here. Why is it important that our consciousness is made of physical matter for materialism? Why is it important? I don't know how to think about the framing of the question. It's just, I don't know whether we would say it's important or not, but that's just the definition of the concept. The concept is that every single thing's made out of matter. Now, okay, take for example this marker that's in my hand. Don't you think it's made out of matter? Sure. I'm sure that you don't have any problem believing that like inanimate objects, like this table, this chair that I'm sitting on, the whiteboard, the marker, no one would look at that and say that's made out of like a spirit or a soul, you know? So you have no temptation whatsoever to look at other things in the universe and say that they're made out of anything other than matter. So where does the description of a thing that's not made out of matter come into the picture? Only when you start thinking about your mind and your thoughts, feelings, experiences, ideas, right? If you're thinking right now of, I don't know, a childhood memory, right? Put that in your mind. You might be thinking, well, it's very hard for this concept of my memories to be something that's just built out of atoms. But according to materialism, everything else is built out of atoms. So how could there be two different sets of physical laws? One that governs the behavior of matter as it moves physically through space, and another set of laws that cannot possibly speak about matter, which has to do with consciousness. So it would not be parsimonious, right, to say that there are two unique different types of substances in the world, mind and matter. According to a physicalist, this is a synonym for materialist, so according to a materialist, what your consciousness is just your brain and the brain processes of the brain. So, you know, your brain has neurons, synapses, and the electrochemical functioning of the brain and the parts of the brain is the only thing responsible for your consciousness. If there was something more to consciousness than the brain, then what would it be? It would have to be something that somehow defies physical analysis, like a soul or a spirit or a ghost. But that's unscientific because there's no possible way to observe such things, since by hypothesis they're claimed as supernatural. What you're saying is, would an explanation then be that our consciousness is based off of chemical impulses? Yeah, so since you're asking these questions, going back to my example of the marker in my hand, do you think this marker has consciousness? What do you think? Do you think this marker is like chilling, wondering how cool this lecture is, thinking about the topics that we're all discussing? I hope it's just obvious. I asked that question because it's a rhetorical question. Obviously the marker, we can agree, right? It doesn't have consciousness. But you do, and I do. So what's the difference between us? What do you think? What could it possibly be? Well, here's what the physicalist would tell you, what the materialist would tell you. It's because there's no physiological structure here in the marker to produce consciousness. There's no central nervous system, there's no brain. So it's not the kind of object that is capable of generating consciousness. But you are, and what's the difference? Well, is it a coincidence that you have a brain and that you have a functioning nervous system? So it would seem like there's a one-to-one correspondence between things that have consciousness and things that have functioning brains. When there's inanimate objects, tables, chairs, rocks, the reason they're not conscious is not just magic. It's because there's no functional neurological structure to produce the consciousness. So wouldn't that go some ways towards establishing this point of view, that where there's no brain that functions, there's no possibility of consciousness? Because where could it possibly reside? Will it be disembodied? Will it be floating free from the body, just out there, but not attached to any physical system? If that was true, then why didn't you have consciousness before you were born? If the soul was already there, then how come you don't have memories of waiting to be born when your soul was disembodied prior to the existence of your physical body? So, I mean, you know, there's all kinds of different common sense and intuitive arguments to be made for materialism. But I guess some people, of course, and a lot of people don't agree with it because it eliminates the possibility for there to be a soul or an afterlife. Because when one's body is returned to ashes or dust, as we all know happens eventually, then there cannot possibly be the functioning of the nervous system or brain. And therefore, consciousness would be erased or eliminated from the world, but the body will be there decomposed. So it's materialism. You understand what I'm saying? It's a viewpoint that there's just matter and there's nothing spiritual, there's nothing paranormal, supernatural. There's just atoms, basically, and you're just a big bunch of atoms put together a certain type of way. The fact that you're able to even experience this lecture or think about anything or, you know, listen to music or, you know, have memories is just because of the existence of your physical brain. Paley, you say, what is the opposing school? The opposing school of thought is what is called dualism. Okay, dualism says there's matter, but there's also something called a mind, which has no physical substance, but is somehow conscious. That's the viewpoint that Descartes and some other classical philosophers have argued for, and there's still a healthy tradition of dualism. I'm not telling you materialism is the only viewpoint. I'm not telling you that dualism is false either. But what I am saying is that as far as science goes, materialism is a working assumption, because science as a field is to those things which are observable, testable. And if something was outside the realm of physics and outside the realm of physical matter, then it could not possibly be the subject matter of a scientific inquiry. So scientists, whether it's true or not, assume that everything's made out of matter. And I've tried to give you guys some reasonable basis to think that there's some common sense behind that. But there are other ideas, and dualism is the major alternative. Dualism says there's matter and there's mind. And most things are made out of matter. But then when they have conscious beings like me and you, we are also, we're like a mind inside of a body or something. And the mind is not to be confused with the brain to a dualist, because the mind is like the soul or spirit that has no physical extension, volume, mass, or shape. But the brain is the organ in the skull. So dualists distinguish between your physical body, even the brain, and the mind, which is kind of like a philosophy term for soul. But scientists that are like, committed to the methodological assumptions of science take the assumption of materialism instead. Okay, so maybe that's why some people have had the thought, and it's probably true, that if you're a really thoroughgoing scientific realist, you don't believe there's a soul, you don't believe there's an afterlife, you just think there's living matter, there's flesh and blood, there's animals, we're animals, born and die, and that's the whole life of a conscious being. But anyway, I mean, it's very deep, isn't it? But this is philosophy, so what do you really expect? So that's materialism, another basic fundamental assumption of science. Okay, so we go from there. Another major assumption of science is what's called predictability, okay? Predictability. So this is the assumption that the universe is orderly and predictable, which means that if we have established a cause-effect relationship in nature, that is not going to be just a one-off, random, one-time occurrence, but that it would be repeatable into the future forever. So let me give you that definition, and then we'll talk more about it. It's the belief that the universe is orderly and predictable, meaning that established cause-effect relationships will be repeatable and will hold forever. Will be repeatable and will hold forever. Okay, there is our definition of predictability, a third guiding assumption built right into the heart of scientific practice. Okay, so let me explain this by means of an example here. Going back to this marker that you see here in my hand, which I'm writing the notes on the board with. It's in my hand. My hand is, holding it at a height over this table. Now it's in my grasp, but I have control over the muscles of my fingers and hands. So what I'm about to do is release my grasp from this marker. What do you predict will happen if I do that? I have not done it yet, but I'm telling you I will do it in just a moment. What do you predict will happen if I open my grasp, which is holding this marker? What do you think would happen then? Have a prediction? You say it will fall. Okay. Now, I pretty much agree with your prediction, but let me just, play around a little bit. How do you know, though, that it's going to happen? Because I haven't done it yet. How do you really know? I mean, how can you know if I haven't done it yet? What makes you think it's going to fall? Why do you think so? Chris, well, you good. We're giving that correct prediction, I think. But what is your prediction based on? What makes you think that it's going to fall? What are you going off of? Okay, so Carmen, good. You say, because when I've held things and let it go, it always falls. I like that response, but Veronica, be a little critical here. And same with Chris, you're saying gravity. Okay, but what makes you think gravity is going to work today? I mean, it used to work all the time up till today, but what makes you think it's going to keep working today? I mean, maybe gravity just stops working on April 23rd, and then from here on, it stops. What makes you think it'll keep going? You say gravity, right? But my question is deeper than that. Why do you even think gravity continues to work? Why should it work today? Just because it worked in the past, why should it keep working? That's very good, John. It's induction, isn't it? It is induction. Because it has worked in the past, we induce to the next case, saying, well, you know, having seen it happen this way in the past, it should continue to work that way in the future. You say the Earth is still alive, so it will still work. I mean, it doesn't need to be done on the surface of the Earth, though. You could be up on the moon and bring an object up there and drop it on the moon. I mean, it should fall there, right? So it's not only about having to be on the planet Earth. Any other closed physical system which had the same physical properties should reproduce this effect. But anyway, basically what I'm fishing around for is for you to give a response like this. Well, you think it's going to fall because that's what always happened in the past, right? And don't you believe that this universe we're a part of is predictable enough that the way things happened over the past will continue to be the way things happen in the future? So let's just test it out. Ah, of course, it did fall. Now, how many different times, if I had infinity of time, if I had just eternity, right? If I was an immortal, and I could just stand here giving this live stream to you guys forever, wouldn't that be beautiful? But if I could do that, and I could just keep opening my graphs when it comes to over and over again, perpetually, how much time into the future do you think it would keep? Do you think it would keep falling 100 times, 1,000 times? How many times do you think that would keep happening each time I dropped it into the future from now? Should that keep happening for 5 years, for 10 years, for 100 years? How long in time do you think this pattern will continue if I were able reproducing it? Okay, good, Veronica, forever. And that's what this assumption is all saying. It's just saying that when we've noted or kind of understood a cause-effect relationship in this universe, the universe is so orderly and predictable that that same phenomenon would be reproduced in any future case. That it's not just something that happens here and now, but it happens there and then for every time and every place. So it wouldn't just be on the planet Earth that the pen would drop, but if I went to another planet of similar mass, it would drop there too. And then Chris, you say it depends on how many drops I guess. I don't know what you're thinking. Are you thinking that happen even if I had a million, billion, infinity number of times to drop this? Because the laws of physics are claimed to be things that are permanent. Permanent in their application and universal in their extent. So science assumes that. If we didn't assume this predictability concept, then we would keep having to, let's say, revise our understanding of solid, established scientific principles. But we don't think that gravity just works temporarily or within a limited scope of space. We think that that property is something that is fundamental to the entire universe and the nature, the laws of nature. So an established cause-effect relationship is believed to be something repeatable forever. But, right? It's an assumption because basically we have to presume that that's what will happen since we don't actually have access to the future yet. We're living right now in the present. And what will happen in the next time I drop the marker, I guess we have to wait to see until I drop it. But we think that the universe is so predictable that these cause-effect relations will always hold. So that's another big assumption of science. If that was not built into the practice of science, then we would always look at our understanding of nature and cause-effect as something that is temporary and subject to revision. Now, honestly, in science, it is said that theories are only true to a high degree of confirmation, and there's always the possibility that new information will invalidate an existing theory. But we make the assumption anyway that when we've got a really good, clear understanding of a cause-effect relationship, that's not going to change. Okay, so that's predictability. And then one more of these basic assumptions of science. It's what is called the assumption of unity. This is the belief that there's an underlying unity to the universe, which means that everything eventually will be able to be explained according to a single set of scientific laws. Okay, so there is an underlying unity to the universe such that everything can be explained according to a single set of scientific natural laws. Okay, so there's a unity to this universe, meaning that everything can be explained with just one set of scientific laws. So scientists hold out the hope and belief that at some certain time in the future, we will have a comprehensive set of scientific laws and principles, which we can use to explain the occurrence of any event in the entire universe. So the belief here is that we'll be able to use a single elegant set of principles to predict and explain the behavior of everything, all the way from the biggest scale of reality to the smallest microscopic scale. So we should have one set of laws and principles that explains the behavior of, the largest level of description, like galaxy superclusters and the accumulation of matter in space at that massive level of description, all the way down to like fundamental particles of the universe, quantum behavior of particles, and so on. Now, the thing is, this is kind of a dream, though, of science, which has not yet been fully achieved, because as of today, we actually have two different set of laws and principles. One for the small scale of reality, that's quantum physics, and another for the large macroscopic scale of reality, and that is the theory of relativity from Einstein. And in the margins, these two fields of explanation actually contradict each other. So the belief is that eventually we'll find some type of bridge between quantum physics and the theory of relativity, which will bring the two together and allow for this unified set of laws. People think, scientists and philosophers think, that it would not really make sense for the universe to have two different distinct sets of laws, one governing the behavior of elementary particles, and another set of principles governing the behavior of macroscopic, larger levels of reality. But that is yet to be fully accomplished. As of right now, there's still work for living and future scientists to integrate quantum physics with relativistic physics. But anyway, that's a belief of science because it's one universe, so shouldn't it just work according to one set of principles, whether it's the big stuff or the small stuff? Okay, so those are some basic assumptions of science, and now that we've gone over those, empiricism, objectivity, materialism, predictability, and unity, the next thing we're going to speak about for a moment are what are some limitations of science? Like what are some things that science assumes but really can't prove? So, limitations of science. Now, this part of the chapter 12, in my view, it's quite, philosophical and heady. So I didn't want to overwhelm you with too much difficult intellectual gymnastics on this point. So I'm just going to kind of talk us through the limitations of science, and then we'll return to more concrete notes in just a few minutes when I finish this little brief explanation. But basically, okay, so here's one limitation of science. The assumption is made that the external world exists, and that the world that you appear to see around you is not just a dream you're having or a simulation. So scientists have to assume the existence of the external world. but I guess it can't exactly be proven. Because if you were, for the sake of argument, dreaming right now, or in the middle of a grand simulation or illusion, like the Matrix or something, or Inception, if that's what was happening to you right now, then there's no way that you'd be able to prove otherwise, because if the simulation was that realistic, then you had nothing to compare it against. So we don't really, I guess, know for 100% fact that the external world is real, but we have to assume that. Otherwise, there would be no point to studying anything. I mean, if you're like Mario, right, and you're living in the Mario kingdom, what would be the point of like learning about the physics and principles of science that govern the behavior of the cartoon video game universe you're in? Because it's not even the real world, right? So if you're like a character in a simulation right now, then any scientific knowledge you get about the world is knowledge about a fake world that doesn't even really exist. So science, of course, assumes that we are in the real world and that the external world around you is not just a hologram or an illusion or a dream. If we didn't make that assumption, then science would cease to have any real point. So that's another assumption, but it's a limit. It's a limitation because it's something that's assumed which can't ultimately be proved. But we're just going to grant that for the sake of common sense and also for the sake of practicing science. Another limitation of science is that it's all about things that are observable. Paley, John, your question, where does the thought of unity originate from? I guess it sort of has to do with the principle that scientists have, which is that the universe is elegant and parsimonious. So we seem to have discovered through advances in physics and mathematics, like we've unlocked great knowledge about the way that the world works. For example, we've built atomic bombs, microwave ovens. So some of our technological achievements demonstrate that we actually do have some clear insight into the workings of nature and reality. If we didn't, then none of our technological advancements would work. Obviously, they're based on correct principles because they do work. So I feel like that's a proof of concept that science is getting something correct about the way it understands the world. But why would a scientist think that there's limitations to how much you can learn about this world? The belief would be that over time, building on the backs of previous predecessors, we'll get to a clear-headed understanding of everything. And that when we get there, we'll know about it in a way which provides us with a single set of principles. So it's just kind of like a projection of the scientist's ultimate dream or goal, to have a full understanding of everything, not just some things, not just a partial understanding, but an understanding of everything. And if there's one universe and there's one set of physical laws, then maybe we could actually discover them. I don't know, it's kind of just like it's the normative goal of the field of science to have a fully satisfied explanation for everything. And the idea that there's only one set of laws, I guess, originates from the belief that there's only one universe. So if there's one universe, there should just be one set of laws, not two sets of laws. That would imply that there's disjoint elements to reality that don't have a logical connection to each other, that cannot be integrated. Okay. But another, as I was just mentioning, limitation of science is that it's all about the things that are observable. As we said to just begin the whole lecture today, science begins from the observation of facts to testable explanations for those facts. But if there's something that cannot be observed, even indirectly, then that's going to be always something that science would have a hard time fully explaining. As one example, physicists and astronomers have noted that if you examine the movement of objects in space, it appears that everything is becoming less dense. So what that means is that everything is expanding outward from everything else, and the universe seems to be growing in size as every piece of material gets further and further diffused from everything else. Now, why is it that this outward expansion is happening so fast, and how come the forces of gravity are not causing a contraction of all the matter? There has to be some force responsible for this outward expansion, and one candidate for that is the idea of dark matter. Is it dark matter that is driving this forceful expansion of all material outward? Because it's happening in a way that's not even fully explicable on the hypothesis that the Big Bang explosion is the source of the outward motion. Now, dark matter is called dark matter because it can't be observed. And so if it's this thing that's causing this expansion of the universe. It's going to be something that's very hard for scientists to fully comprehend, because being as it is dark, there's no way that we'll be able to really, at least directly, observe it. So one thing that's difficult for science is explaining things that are outside the realm of the physically observable. And some people also critique the predictability assumption that I mentioned earlier, like that natural laws will persist forever and never change into the future. I mean, we have to make that assumption, but again, it's something that is a limitation, because we can't prove that that will always happen. We just have to assume. Okay, so that's some limitations of science. Now, what I want to go over now for the last few minutes of this meeting today are what are some views that people have about the relationship of science and religion. The textbook mentions 4 basic views about the relation of the two. So let's talk about that. 4 views about the relation between science and religion. Okay, so many of you have probably heard the general idea that science and religion are in tension with each other, that they don't agree, that a person who holds a strictly scientific view of the world would have to disagree with certain religious claims, or that a person who's really a devoutly fundamental religion practitioner would have to reject certain scientific claims. And yes, there are definitely discrepancies and differences between the beliefs and claims of science and religion. So what attitude should a person like me or you take toward these conflicts between religion and science? Okay, well, there's 4 possibilities. Let's go over them. So one of them is this, that science takes priority over religion when the two conflict. Okay. And number 2, different view, is just the opposite of this, which is the idea that religion takes priority over science when the two conflict. So I'm going to put 3 and 4 after I discuss these 2, because the board's full. But let's go over these. So first of all, number 1, this perspective is the viewpoint that when science and religion come into conflict and they disagree on something, some people will say, well, there you have to break in favor of science and reject the religious view. So, like, say, for example, that there's a religion that says that the planet Earth has only existed for 5,000 years. But then there's this scientist that says, no, we have carbon dating of fossils, and it's clear that there's been, living beings on this planet for literally billions of years. That seems to be a big discrepancy, right? The age of mankind or the planet Earth, according to this one religion, versus the scientist. Now, who's correct? What should one say in view of this conflict? If you hold number 1 point of view, then you would opt for the scientific account and just say the religious account here is wrong or misguided or something. Another possibility, in the Bible, in Genesis, it says that God created the universe in 7 days, and on the 7th day he rested, right? So that would mean that mankind was created within the first week of the universe's existence. But that's not at all what science tells us. It says that mankind is actually very late to the whole party, if you like to use a turn of phrase, because it took billions of years for planets to form, and then it took billions of years for human life to evolve on the planet Earth. Whereas in the beginning, it was largely microbial, and then it took much longer for vertebrate and mammalian life to emerge. So that's a difference, isn't it? Did it happen within the 7 days of creation, or did it happen over this very long gradual process of evolution that took billions of years? If you hold this view, number 1 view, then you're going to prioritize and prefer the scientific account and reject the religious one. But of course, there's all types of options for a person in terms of their views. So a different view is just the opposite here. And that would be like the contrary. So if the religion says God created the universe in 7 days and the scientist says that's not what the scientific evidence shows, then this second type of person would say, well, I'm going to prioritize and prefer the religious account, and I'm going to reject what the scientist is saying. Maybe the scientist is misguided, misinformed, I don't know, but the religious authority is coming from God, and some people are going to say that that's the higher authority that they defer to in conflicts between these two realms. So those are obviously two options. This is more the option of the secular, scientific-minded person. This is the more devoutly religious, adherent in the second case. So clearly there are discrepancies between science and religion, whether it's creationism versus evolution, the origin and nature of man with relation to the cosmos, the position of the planet Earth. Remember, that's just one other example of this. At one time in the church's history, it was a conflict between the astronomers that were showing the Earth's not in the middle, and the church saying, well, that's what Orthodox church doctrine says, that we are in the middle. So you would see people dividing on those counts according to which view they have here. Now, there's a third possible view, and there's also a fourth, so I want to put those on the table too. A third view is that there's no real conflict, actually, because science and religion are dealing with different topics. So that's a third possible point of view. Science and religion deal with different topics. And then the fourth view, just to kind of put them all on the table, is that science and religion, there's no disagreement because in the end they actually are compatible. So that's the fourth view. Science and religion are compatible. Okay, so number 3, what it says is science and religion are dealing with different topics. So some people believe this. Some people say the apparent disagreements and conflicts that occur between religion and science, they're not really real conflicts because, in fact, they don't even talk about the same material. You could argue that science deals with the physical universe and causal processes of cause and effect. But religion deals with the spiritual and the moral side of life. And these two things have no overlap. So you could argue that there's really no overlapping portion of two, let's say, circles on this Venn diagram. There's religion dealing with its material and topics, the soul, the spiritual, the moral. And then you've got the scientist that's dealing with material processes, cause-effect relations in nature. But these two things don't have any overlap. So that's another possible view. I find that to be somewhat hard to fully sustain, though, because if you just take just a superficial glance at what religion and science do talk about, it seems that at least in some cases they definitely speak about the same topics, right? Because science talks about the origins of man and life and the universe and the placement of the earth and so forth. And religion does, in some of the scriptures, make claims about those things too. The genesis of mankind, the Garden of Eden, et cetera, being created in his image, fully formed, not evolved from great apes. So it's hard to just dismiss the at least appearance of conflict between the two realms, but some do, and that's another viewpoint. Finally, number 4, that's the perspective that there's no conflict or confrontation between them because they're compatible. Compatibilism in this case would mean that people perhaps want to reinterpret the religious doctrine so that it actually accords with what the scientist says. So this is, I feel like, sometimes a clever attempt to make the two things actually appear to no longer have any disagreements. So for example, maybe some of you have heard this kind of argument used before. Someone who's really into the scientific way of looking at reality says, come on, religion's fake and false because it says there that man and the universe was built in 7 days. But science tells us there's no way that's true and that it took literally billions of years for life, and especially human life, to appear. So how could maybe somebody say, well, you know what, that looks like it's a conflict or a disagreement, but it's not really a disagreement because you just have to reinterpret something about the scripture. So what might somebody say is the true meaning of the scripture when it says God created the universe in 7 days? if they want to try and make that statement consistent and compatible with the scientific research that shows a different number? How do you think someone might try to, I don't know, modify their interpretation of the religious statements of the Bible to make them conform with the scientific research? What do you think about this case? Universe made in 7 days. How could that possibly be consistent with saying that it took billions of years for mankind to appear? How could someone try and finesse this into making, consistent sense? They're really saying the same thing. They're not saying two different things. The Bible's saying the same thing as a scientist. It's just because in the Bible, yes, good, John, you could argue that those scriptures are figurative, they're poetic. So 7 days is not literally a 7-day period of 24-hour cycles like you have on the Earth as it rotates on its axis and is showing a different face to the sun over 24 hours every period. You might argue, well, that's metaphoric. It says 7 days in the scriptures, but it really just means an arbitrary length of time, whatever a day of God's, life would be. So it could be innumerably many years. So that's another popular attempt to iron out the kinks and differences between the two, to just sort of again, reinterpret biblical literalism so that it kind of squares with the scientific account. Well, you're saying, Chris, that it's just belief, so it's not true stuff. I mean, that's a controversial statement. I don't know. I wouldn't presuppose one way or the other just as a teacher. And a lot of people, of course, the majority of people do believe in God and religion. But it's my duty here to teach you guys a little bit about science. And clearly science is not the same as religion. But what do people say when the conflicts between the two domains are put out into the open and discussed? Some people hold this fourth view so that they can kind of have it both ways. I accept the scientist's claim, but I also don't reject the religious claims because I see them as being capable of interpreted in a way that is the same as the scientist. The only thing about number 4 that I find a little bit unsatisfying is, why has the reinterpretation been affected when it has been? It's not like people were interpreting biblical scripture prior to the establishment of the theory of evolution and defining days in a different way. The most ordinary interpretation of the word day is to transfer your understanding of day from your human life to the scriptures themselves. So it seems as if it's kind of ad hoc, right? It's only after scientific discoveries put pressure on traditional scripture that people start to say, well, maybe we should reconsider what we really meant by that scripture. But I find that to be somewhat, in a way, cherry-picking the data to fit the hypothesis, right? Like, if somebody fires an arrow at the side of a barn and it just hits anywhere on the barn, then they walk up to where the arrow is and they draw a bullseye around it. Is that a skilled marksman that really has a great shot? No. They're just telling you, well, that's where the bullseye is now that I've hit somewhere on the barn. And so when a scientist says, here's the theory of evolution, that's not at all what the Bible was claiming. Now it's like the defender of the scripture may say, well, okay, I'm just going to give you a different interpretation then. So nothing you say could possibly count as disconfirmation for the religion. So, I mean, there's certain ways of looking at it where it seems hard to square the circle there and make them consistent. You might argue that it has to do with cognitive dissonance. John, you might say people, they're being torn in two directions and their commitments, they want them to be consistent even though they seem to be on the surface inconsistent. Yeah, it's possible. I don't know. So anyway, you are an individual, each of you, and you have your own judgments in life to make, right? And each of you is going to hold a view something along the spectrum of 1 through 4. Some of you will say, scientists just wrong when they contradict religion. Or you might say the opposite. Religion's wrong if it says something different from science. Or you might say, like these two, they have their own different subject matter. So they're not even they're in their own different lanes. They're not even interfering with each other, stepping on each other's toes. Or you might be that person who says, let's open up the space of scriptural interpretation in a way that gives us some kind of consistency between both realms. But anyway, that's a little bit more on religion and science. Kitty's here again. She's always hanging out with me. So yeah, there's more on chapter 12, but this is devoted to 2 lectures actually. So we have today and then Tuesday after the weekend. So my thought was, I don't want to rush through too much of the notes today, even though we still have 10 minutes, so that there's ample time to have evenly spaced class periods. So let's just, I think, unless there's more questions, let's kind of adjourn for now and have a great weekend. And then on Tuesday, just come back to the next live stream, same time, and we'll finish chapter 12. Then Thursday next week, we do have this quiz on chapter 12 of science. So everyone should read chapter 12, make sure that you have a good understanding of the pages that are set out in the syllabus, and taking good notes and watching these live streams. You should be prepared pretty well for our quiz next Thursday. Okay, that'll be the last quiz. Then I'll assign the last homework. And then from there, it's just down to the final exam. And we'll make sure to give you a study guide and prepare for that too. So I guess that's about it for now. Thanks, everybody. I really appreciate you guys sticking with it. I know it's been a crazy semester for everybody and stuff, but it's not over. You're still in school. We still have a little bit of work to do, but we're getting close to the end. So don't give up now. Make sure you stick through to the finish, and you'll definitely be rewarded with a solid result if you can. Okay? So thanks, guys. I will definitely see you back on Tuesday. Have a good one, and take care. Stay safe.